And so this is the disassembly line. I'll talk about how to put this disassembly line together, and this will be useful for new teams setting up or moving between locations. So to begin with, we're going to both talk about what happens and how the setup works out. The very first thing that happens to fish during the process is kicking bottles over. And the fish are going to be put into a container of tricaine that's buffered with baking soda. And it's 1 tablespoon of tricaine to a teaspoon of baking soda mixed into about 2 cups of water. The fish go in until they stop moving, no more apercular movement, and they lose their equilibrium and turn on their side a little bit. Give them another couple seconds, and they should be good to go. If they move when you pick them up, obviously they go back in until they're done. And you want to ideally just do 1 fish at a time, especially when we're dealing with the gene expression material and spleens. Each fish is going to be put on a rubber mat. The rubber mat will be accompanied by a paper slip. We print these out in advance on Write in the Rain paper with 4 IDs per fish, and then we use scissors to cut them into these cone-like strips.
Okay, yeah.
And so you pull off one of these strips, and we'll put it on the mat with the fish. And that whole strip will accompany the fish down the line. The fish will get weighed first on a scale and read out to the note taker who has a clipboard and a data sheet. And you don't just read out the mass, you read out the fish ID. You say fish number 3. Here's the mass. You then have standard length, and you want to make sure that the calipers are functioning and have some spare batteries around. We'll show later how to do the standard length measurement properly.
So something that is really, really helpful is that whoever's writing down the number should repeat back what they heard. Because you'd be shocked at how many times those things are a little bit off.
Especially the fish ID, because those can get mixed up. So using a battery as an example of the fish for a second, the fish will have a scale next to it, and that's going to get put in the camera box.
Along with its ID.
And along with its ID. The camera box folds up, and so you just have to open it up. It velcros together into a box. I'm going to talk briefly about the setup of the camera. So if we come around the side, the camera is attached to a tripod. It comes off with 2 steps. You have to depress this lever here and then turn this lever. If you just turn this lever, it's not going to come off all the way. So you got to do both. A latch here, you can unscrew this to remove the camera. You need to do that in order to get the micro SD card in and out. The tripod should be high enough that the camera is no more than a couple inches above the top of the photo box. We could actually lower this one a little bit, I think, profitably. And then you want to just make sure that it's level. So you walk around and you check to make sure it's the top of the camera that should be level. And so if need be, you can loosen some of these knobs, adjust the angle. You can change, shorten a leg, lengthen a leg in order to get the top of the camera nice and level. That ensures that you have a straight down image. If the camera is tilted one way, you get a little bit of parallax in the lens that warps the image just a tiny bit, but best to avoid it.
So FYI, I'll try and get one at the hardware store, but there's circular levels that you can put on top of it and level the camera that way. But you have to make sure that's level too down there, right? Because the idea is you want the plane of the fish to be identical to the plane of the CCD array that's capturing the image.
You notice the camera is plugged in, and that way the camera doesn't shut off. You want to make sure the camera is set in the settings menu to always be on. You don't want it to auto shut off, because if it does, it completely closes up and you lose your focus and zoom settings, and that's not ideal. So you turn the camera on the very first time, and then hopefully it stays on the entire duration. You want to zoom in as far as you can, but you notice that if I zoom in, And listen for a sec. I'm going to press the shutter button down halfway. Hear anything? No. That's because it didn't focus properly. It beeps when it autofocuses. If it zooms in too much, it won't autofocus. I'm going to zoom out a little bit. Still no beep. Zoom out a little bit more. No. Autofocus. Now I'm going to zoom in a tiny bit more. No beep. Perfect. So that's the maximum zoom that will autofocus. That's what you want to reach. And that's why you don't want it auto shutting off, because you'll have to redo that and it won't be exactly the same every time.
But is that going to be every day we have to reset it?
Yeah. Then you just want the fish centered right in the middle of the image. And then when you take your photo, you don't want to jostle because you don't want to blur the image. So you squeeze. You don't push the button, you pinch. And so finger on both sides, beep, it's focused. All set.
So so the fish has to be like in the center of the image, right? So this is the focus part of the image. And that could get off position too, potentially. But yeah, just make sure you're focusing on the fish, because otherwise you'll focus on something beneath it, and then depending on the depth of field, you won't have a good focus on the fish.
And if you notice, there's a little cow sticker on the bottom. That's your center. And so if you put the fish over the cow, if you focus the camera on the cow, you're going to be okay. Fish comes out. I verbally confirm with the note taker. Photo is taken. Okay. And the labels need to be visible on the picture so that we can go back through later. We'd love later on to get barcodes to automate that process. That's hopefully in the works. Okay. The measurer and photographer keeps this and moves on and hands this off. If the dissector is busy, the photographer can go ahead and cut the fish open. But the opening process is part of how we learn about the fibrosis score. And so it's ideal that the person scoring fibrosis is the one opening. So the fish gets dissected. We'll have to do another video about the dissection process separately. And gets handed off here. The first thing when that fish gets opened is the person checking it out is going to visually evaluate for fibrosis. Then if there's a tapeworm, and sometimes you have to look for small tapeworms, if there's a tapeworm, it gets taken out, put in a tube, and labeled with the fish ID. You can put multiple tapeworms in a tube as long as they're not too big. Sometimes you have a bunch of big ones and you need multiple tubes. The fibrosis score is read out to the note taker, and the spleen is removed by dissection, and we can do a video of that process later and hand it off to the spleen team for freezing. And there are little trays that the spleens go into. And there's a whole set of these.
Yeah, the molds are filled with OCT.
Okay.
Yeah.
The molds are filled with those.
Actually, do you want to explain how? Sure. So we have molds that comes with the labels for the specific lake, and we collect 25 spleens. So each mold is filled a little bit with OCT. You don't want to fill it up completely. After taking the spleen, we add the spleen to the center of the mold, and then whoever is freezing there will fill it up with the rest of the OCT up to the brim. You don't want to overflow it. Fill it up to the brim and then put it in the freezing mixture, which is basically a mixture of dry ice and methyl butane. You want to put it in such a way that the mold is floating on top of the methyl butane. You don't want to immerse the mold completely into the methyl butane. So as it starts to freeze, you will see the OCT will turn opaque, it will be completely white. And then once the freezing is done, you would wrap it up with saran wrap first, and then wrap it up next with foil. And then we have a label that goes outside. We will add the label to it and then put it in the dry ice box. You want to keep it in close contact with the dry ice box. So yeah, completely tuck it inside the dry ice. So that's the short process of the spleen freezing.
So moving on to the setup over here. We have two microscopes that are set up with cameras. The camera is this blue box here. It's turned on. It has a HDMI cable over to a screen, which has a little switch at one end over here to turn on. There's a mouse and a power cord. The camera is inserted into a photo tube, and you can loosen a screw on one side of the photo tube right here. You can loosen that and adjust the height of this. It can go all the way in, it can go up part way. Part way seems to improve the focus a little bit. The focus of this camera is a little different than the focus you see through the eyepieces, and having this up a little higher helps make those things match up. If you see something that is worth documenting by photo or by video, this will function for that purpose. So we need a light source next to our dissection. I'm just going to put one of our dissection tools here for the time being. To activate the screen, this is on already. There's a metal pin here that gets pulled out. And when that gets pulled out, it switches a mirror here that allows light to go, instead of to both eyepieces, light goes just to the right eyepiece, and the light that would go to the left eyepiece is now being diverted over to the camera. So you will not be able to see in binocular vision anymore, but you can still look through either one eyepiece, and you can also see it on the screen. We can adjust our focus here. And so now we have an image of the end of this. And it's actually pretty nice. If you don't need binocular vision, this screen can actually be much easier on your eyes and on your back. So you might even think about experimenting with just using the screen and not using the eyepieces for some purpose. The mouse here controls your photograph. All you need to do is come over to the left side, and there's a option for snapping a picture, or an option for recording. If you hit record, it'll record, and you click it again to stop recording. To see what you did, you need to come down to the bottom and look at your browser, and the most recent image will have an ID number. If you take an image that you want paired up with that individual fish for some reason, like it's a picture of a parasite you couldn't identify, then you need to tell the note taker what that photo ID or video ID was. It only shows on the screen for about a second when you first take the picture, so you either have to be paying attention, or you need to go into the browser here and look at the most recent image. And then you just click on home to go back again. Again, left side, snap an image, image 001. And then there are some settings, and there's some nice settings in terms of exposure and color and so on, but we don't really need to play around with those for present purposes. So the spleen is removed. We've gone over the spleen. Fibrosis is scored. And then people at either of these two microscopes can examine for parasites. We have a document on the common parasites. If you are confident of what you're looking at, great. Tell the note taker what kind of parasite and how many. Certain parasites are extremely abundant, and it's okay to do kind of tens. You know, this has 30, this has 50, this has 120-ish. You don't need to sit there and count individually. It is not important enough to get that number. So if you are unsure at all, take a video and move it around, like point to it, move it around. The videos tend to work better, I find, than still images, unless you feel like a still image worked pretty well. And again, read it off to the note taker so we can go back and I can say, oh no, that was really an Ascaris. We need to change the ID on that. I need to know which fish that came from to pull that off. At this microscope, sorry, back to this one. Last thing is the liver gets removed. Half the liver is going into an RNA later tube for the first 30 fish. Half the liver is going into a tube with ethanol. The RNA later tubes should be, they can stay at room temperature for the time being. Eventually they will go into a freezer back in the lab. The ethanol liver is for metabolomics, and that can just stay on the shelf for the time being.
And that needs a tag to go into the tube. So at that point, you rip off one of the tags and it goes into the tube.
This station is primarily for head kidney, which is a more labor-intensive dissection. It takes a little while. If we find that this first microscope is taking longer, then the parasite ID will get shifted over to the second microscope. So there are 2 people who can do the parasite stuff. Head kidney comes out, again, just the first 30 head kidneys. After that, this person is only doing parasites. Sex and whether, if it's a female, is it gravid? The way we define a gravid female is at least a third of the ovaries are what we might consider mature eggs. So we see a reasonable number of eggs that are close enough to being crossed that we think this fish would spawn in the next week or so. It's a fuzzy boundary. There's not a great way to have a sharp contrast. It's the third, at least a third of the ovaries looks like it has nearing mature eggs. Next, the fish comes to the gut microbiome station. Sarah, do you want to explain the gut microbiome process?
Sure. So basically, you want to get the entire gut, including the stomach, anterior and posterior gut. You want to get the entire thing without bursting the gallbladder. We don't want the gallbladder in there. And if there's any excess fat, it's generally going to be sterile, so we can keep that on, but try and remove as much as possible. You want to dip your tools in 10% bleach and then in 70% ethanol to ensure that everything is sterile. Once you put the gut into the tube, you're going to immediately flash freeze it on dry ice.
And the tubes are pre-labeled and empty. They don't have any reagent in them. Now the specimen gets handed off to the next step. The eyeballs are for gene expression, for opsins to figure out what the fish are looking at. We're only doing 5 fish per lake. Eyeball comes out, goes in a tube with RNA later. Next, muscle. We get a clip of muscle tissue from the caudal peduncle, a fairly sizable clip of tissue. It goes in an empty dry tube, and one of the labels goes in the tube. Leave the tube open. These need to dry. And so the tubes stay open the whole time. We're going to put them in the oven at the end of the day to dry out. From the muscle, next, it goes to a fin clip. So the caudal fin gets removed with a pair of scissors. The fin goes in ethanol with yet another one of the labels. Tube gets closed. Then the fish goes in a bag, in a tea bag with its remaining label, and that goes in formaldehyde. And just make sure that the fish are getting stuffed down into the formaldehyde. If you need to, once in a while, seal the jar fully, shake it up and down a few times. End of process. At every step of the way, it's good if the note taker isn't too busy to just confirm note taker, muscle's done, head kidney's done. We might find that a little overwhelming, in which case we can omit that, but it's good at least to confirm up through the tubes that things are getting done, partly because it's a way of confirming the specimen ID. Your job as note taker is to kind of keep an eye on things and make sure labels haven't gotten flipped around. If it's windy, labels blow away, people pick up the wrong one. Very rare, but it does happen. So those paper tabs, we have one for the liver metabolomics, one for the eye, one for the muscle, and one for the fin clip. And actually, we don't have quite enough. I think the eyeball will just have to write with a Sharpie.
Yeah, because we only have 4.
We have four labels. So tea bag, fin clip, muscle, and metabolomics. Once we're done with spleen, liver, head, kidney, then this speeds up, but we're still checking for parasites for all of the fish. Still checking fibrosis for all of the fish. So in general, usually one person can do muscle, fin clip, and put the fish in formaldehyde, and they're still not a slow point. One of the other things is both the note taker and or the person at the end here needs to shuttle that blue rubber mat back to the front and just give it a quick wipe off. At the end of the day, a bit about wrap up. Everything should get prepared for the next day. Make sure that you have the tubes you need set up for the next day. Make sure you have the paper tabs cut up for the next day. The camera gets taken off, SD card comes out, and use an SD card reader, which lives in a pocket in the back of the photo box. The photos get uploaded to Google Drive that day. Take a photo of all of the data sheets from the day. They go on Google Drive that day. Videos, photos of parasites go on the lab Google Drive. Boxes, if you have a full box of something like stable isotopes, you filled up a box from the day, or you filled up a box of fin clips, seal it, label it, the lake, the sample ID, the year, what the contents are, and that goes onto a shelf to be shipped out later on.
Perfect effing timing.
Great timing.